Hello 10th class students, as we have finished the atomic structure chapter, now what we are going to do is we are going to start with the periodic classification of elements. When it comes to intermediate, these two chapters repeat: atomic structure and periodic classification of elements. So these videos are going to help you with this periodic classification of elements, better understanding of this particular chapter. So watch them and make sure that you watch them again and again and again, because these videos are the animated versions of the chapter, and therein you can easily understand what what exactly the chapter explains is the same thing you are going to watch in the television screen also. Thank you.
Hello friends, this video on periodic classification of elements part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Now let's understand the Mendeleev periodic table, the best periodic table I can say, the best effort. So this guy, what he did was he arranged the elements based on their fundamental properties, atomic mass, and also based on the chemical property. But chemical property was given the first priority. So at that time there were 63 elements known, so his work was on this 63 elements. He first tried to find the relation between atomic mass and the chemical and physical property. And to find the chemical properties relationship, he selected hydrogen and oxygen because they were very reactive and they form compounds with most of the elements. So he reacted most of the elements with hydrogen and oxygen, and the way it react with hydrogen and oxygen, for example, this is some metal X and it reacted with hydrogen, it gives something, and X reacted with oxygen, it gives something, right? It may be Ra, maybe XH, maybe XH2, right? Maybe in this case, maybe XO, it can give X2O, it can give XO2, right? It can give X2O3 based on the property of the element, right? So it can react in different ways. So similarly with hydrogen also it can react in different ways. It can give XH3, it can give XH4. So based on the reaction of the element with hydrogen and oxygen, he grouped the elements, correct? And then he also used the atomic mass to arrange them, correct? So that is the formula of hydrides and the oxides which you get, the hydrates and the oxides formula which you get, was one of the critical parameter for classification of the element. So what he did was actually he took, for example, 63 elements, right? He took 63 cards. In each of these cards, he wrote this element name. For example, the element name is X, and this guy found some hydride XH and some oxide XO2, let's suppose, right? And atomic masses, let's suppose 58, let's anything. So this guy, he created cards like this. He created 63 cards like this with all the 63 elements name and all the hydrides and oxides and all the atomic mass. Once he had all these values, right, he know all the 63 elements name, he know the atomic mass of all the 63 elements, he know the hydrides and the oxides form. Now he grouped these elements based on these hydrides and oxides. They are the critical thing here. See, if you see the last one, the Newland's law of active, he arranged based on the atomic mass alone, right? So his parameter was atomic mass, and then he found that they have similar chemical property. But this guy, for him, the critical thing is chemical property, and then he's trying to arrange the atomic mass, right? And if he finds some missing objects, he has created gaps also in the tables. We'll explain that, but let's understand that both have a different approach. In the Newland's one, what he did was his primary concern was the increasing atomic mass, and then he found that coincidentally they have repetitive chemical property. For this guy, the critical or the main thing was it should have same properties, chemical properties, that is the kind of hydrides and oxide form should be similar, and then the second critical thing was the atomic mass, correct? So he sorted these elements based on the similar properties and observed that most of the elements got a place in the periodic table and they were arranged in the order of atomic mass, increasing atomic mass. So he was able to arrange them, correct? And he also observed the periodic recurrence of elements with similar physical and chemical property. That's what Newlands have observed. He also observed here also, correct? And on basis of all these experiments he did, he gave a periodic law, right? And he stated that the property of the elements are the periodic function of the atomic mass. This is the law he gave. This law is called Mendel's periodic law. It says that property of the elements are periodic function of atomic mass. Please note it's atomic mass. We don't need the atomic number now because atomic number is not even discovered by this time, right? Because the electron itself was not discovered. All the atomic mass which we use here is all found by the chemical reactions, because the base of all this was the Dalton theory. John Dalton gave this theory in 1804, where he told the mass can neither be created nor can be destroyed, and with that stoichiometry equations, the chemist found a lot of atomic masses, and these was the atomic mass that was used by Mendeleev. I hope it is clear to you. So what he has done was he reacted these elements with hydrogen oxide. He found different hydrides, different oxides, and based on the hydrides and oxide found, he clubbed these elements, right? And then he arranged these elements based on the increasing atomic mass, keeping in mind that all this which forms similar hydrides, similar oxides are in a similar group. I'll show you the picture with that. I think it will be more clear. For example, if you see the hydrides can be R2O kind. Instead of X, they are using R here, or RO, R2O3, RO2, R2O5, RO3, R2O7, and RO4. So these are different kinds of hydride he found, and then he clubbed all these elements, right? And then these are oxides. For hydrides, RH, RH2, RH3, RH4, RH3, RH2, RH. These were the hydrides. So based on these two, he clubs. For example, for these combination, he found these many elements. So he clubbed all these into one group. Correct? All this into one group. All this in one group. So he grouped elements like this. Correct? And then if you see, he called his vertical columns as groups. So these guys were all groups. So group 1, group 2, group 3, and these were all periods, right? They are periods. He called this, used this word groups and periods, which are also used in the modern periodic table. So with this, if you see, everything is atomic mass here, hydrogen atomic mass, and then if you see, there's a lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all the atomic mass, right? And based on the properties, this was the kind of periodic table he found, which was pretty good. Very few limiters in that, but was very good actually. So we'll explain the merits and demerits of this periodic table. So let's do this. Hope you understand how he found this periodic table. So let's understand the achievement of this Mendeleev periodic table. First thing is predicted some of the elements which are not discovered at that time, because when he arranged the elements, he found that some elements are missing, because some of the elements atomic masses were missing, and then he guessed it. He guessed that okay, there will be atomic element which will be found in near future, which should have atomic mass of 68, and he called that guy as Eka aluminum because it used to come before aluminum, and that element was found in future, and we call that element as gallium. And he also guessed the formula of oxides and chlorides. If you see, he guessed that particular element which will have a formula of E2O3 based on his periodic table, and that's what it was. He also guessed the formula of chlorides or hydride to be like this, that is ECl3, and we found that gallium also follows the same suit. So he guessed the existence of some element which we not discussed at the time. Not only the existence of the element, but also the physical, not physical, the chemical property of the elements. He could predict properties of several elements based on their position. As I told, these elements, right? I mean, they were elements for which the property was not found, but based on the position, he could tell, okay, this guy will form hydrides in this fashion, this guy will form oxides in this fashion, right? Because if you see, his periodic table is all based on the oxides and hydrides, right? If you see the way it is formed. So, for example, this guy, he is not reacted, he don't know how it reacts. But just because this guy is in group 7, he can say that this guy will form oxides like this. It will be Br2O7 and will form hydrides like this, BH. So that's what the purpose is, right? So in this case, let's suppose it's very difficult to react this guy with oxygen at that point of time. So what he told, okay, I don't know how to react, but I know that this guy La will react with oxygen, it will form something like La2O3. And if this guy reacts with hydrogen, it will form something like LH3. And that was true also. If you react those things in chemistry lab, and you'll see that that was the kind of reaction it goes through, right? So with just by looking at the position of the element, for example, Ti. So 10, if it reacts with oxygen, if it reacts, it will form TiO2. And if it reacts with hydrogen, it will form TiH4. So those were the kind of things he was able to tell just by looking at the position of the element in the periodic table. Also, he could accommodate noble gas because these gases were discovered at that time only. So once he was done with the table, after that the noble gases were discovered, but he was able to accommodate that. So his table was able to accommodate that. That was one good thing about his table. Now let's see the limitation of this table. The first thing, the isotopes were also discovered that time when this noble gas was discovered, but the position of isotopes could not be explained. As I told, as isotopes are elements with same atomic number, right, but different atomic mass. Right, you see these are all isotopes of carbon, 12, 13, 14. So since they were different atomic mass, they should be different, they should be placed differently in the table, right? But that's what not his table allowed. His table allowed only carbon to be placed once. So the position of isotopes could not be explained that time, right? So this was isotopes were discovered after a long time after the Mendeleev proposed his periodic table. But once the isotopes were discovered, these isotopes could not get placed in the periodic table, and that was not very good. Correct. Also, some order of atomic mass was wrong actually in some case, and that could not be explained. For example, the cobalt was 48.9, it came before nickel, and nickel is 58.7. This guy came, it is like this, 58.9 came, then 58.7 came. There was a debate on this, why it is happening like this, though it was only 0.2 difference, but generally it should be first will come, then second, then third, like this, right? It should not be the other way. So the wrong atomic mass order was not explained at that time, right? Also, hydrogen was not assigned a correct position because hydrogen has the property both of alkali metals and halogens. So if you see, hydrogen behaves like chlorine a lot of times and also behaves like sodium, right? So what should be the position of hydrogen was not confirmed because his classification of the groups was based on the way element react with hydrogens, right? Or the way element react with oxygen, right? So with this, hydrogen behave both as alkali and halogens. So the position of hydrogen was not clear. Also, he could not answer this question. Is it possible to have an element with atomic mass 3 between hydrogen and helium? This was the question. For example, hydrogen has atomic mass 1, helium has, let's suppose, 4, right? So can we have one element atomic number 3 here? Because atomic mass can be any number. It can be 4.08, 4.95, right? So between, let's suppose, 4 and 4.5, you can't say how many atomic mass can exist. Maybe 4.1, 4.2, 4.3, you can't say, right? But if it is something like numbers, I say that some quantity is number, for example, it has to be number, then I can say between 1 and 3, there can be only one number, that is 2, right? But if some quantity is not numbered, because this guy is not numbered, right? This guy is not, sorry, this guy is not, this guy is not natural number. So this guy is not, this guy is decimal number, right? So in that case, I can't see how many decimal number can exist between this particular number. For example, between 4 and 5, between 4 and 6, tell me how many decimal numbers can exist. There can be many because 4.5, 5, 5.2, 5.5, there's so many numbers. But between 4 and 6, how many natural number can exist? Only one. Correct. So since atomic mass was decimal number actually. This is a non-natural number, so it was not possible to tell. If someone asked the question, can there be element between hydrogen and helium? The answer was, I don't know, because they can be, may not be, right? So these kind of limitations were there with modern periodic table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. Using a Mendeleev periodic table, predict the formula of oxides for all these. Right, let's do that. So if you see, the first one is K, potassium. Let's see where K is. K is here, right? It's a group 1. So if you see, for group 1 it is R2O form. So K will be in this form, K2O. Very simple. Next is C. C is carbon. Carbon is here. Carbon is in group 4. Group 4 is RO2 form, right? So it will be R is C, O2 form. So this guy is CO2 gone. The next is aluminium. Where is aluminium? Aluminium is here. In the group 3, R2O3. So it will be Al2O3. Just replace R with Al. Next is Si. Si is where? Group 4. Si has O2 form. So it will be Si. Next is Ba. Let's see where the barium is. And this is this guy. Since this guy is in group 2 and it has RO form, so it will be BaO. And that's my answer. Very simple. With this Mendeleev table, you can actually find which kind of oxides or which kind of hydride will form. Besides gallium, which other elements have been discovered that were left by Mendeleev in the periodic table? These were scandium and germanium. These were the two elements that were left for which the space was left for in the Mendeleev periodic table, and they are found after the periodic table was created. What was the criteria used by Mendeleev in creating periodic table? Obviously, he used the chemical property, right? So he found the oxides and hydrides of the elements, and based on the oxides and hydrides, he created the group, and that was the group. And then ordering in the group was based on atomic mass. So this was the first criteria. This was the second criteria. Why you think noble gas are placed in a separate group? Because they are inert, they don't react, and they are different from all other. Right? They're different from all other. So they are placed in a separate group. Very simple answer. Now let's study the modern periodic table based on Moseley. So this guy, Moseley, in 1913, he showed that atomic number is a better fundamental property than atomic mass. And please note, atomic number itself was found by this guy, because till 1896 nobody knew what electron is. The atomic mass was all found by stoichiometric equations by chemical reactions. 1896, this guy Thomson found electron, and then that was the area where radioactivity was at peak, and this guy was a physicist, and he was able to find a number of electrons in a particular element by the rays it emits, right? By rays it emits. So with that, he was able to find a number of elements, number of electrons, and that is nothing but the atomic number. So he coined this word atomic number, and he found the atomic number for all the elements. And then he observed that if you use atomic number instead of atomic mass in the periodic table as used by Moseley, it overcomes a lot of limitations. Correct? And that's what he did. Also, electronic configuration is a perfect basis for classification of element. So this is also used because There's a property that all the elements in a particular period, will have similar electronic configuration. So with that, we'll explain more when we learn, when we go through the detail of this periodic table, but just understand the electronic configuration of a particular element is the perfect basis for classification of the element. Periodic law can be stated as properties of element are periodic function of their atomic number. Let me spend some more time on the electronic configuration. For example, I have element which has electronic configuration of 282. That means this guy is first, second, third period, right? And this guy will tell you the group number. So this guy is second, that means it is the second group. So this is my element I am talking about. Let's suppose I have element 2, 3. So they are 2 first, second, so it will be in second period. 2 and 3, so this guy is 3, so 3 is group 30, right? So this guy is this guy. So just by electronic configuration you can actually tell the location of the element in the periodic table. We'll explain more on this, but just understand what this guy atomic number did with the Moseley periodic table, right? It calculated everything. The first thing is the position of isotope is clear now. Why? Because isotope, you see that all these elements will have same atomic number. For example, C6, right? You have 12, 13 and 14. But if you see all these have similar atomic number, since they have similar atomic number, there will be only one place for carbon, correct? And that's one. So since it is no longer based on atomic mass, there is no confusion of isotopes. The position of cobalt and nickel is clear now. You see, the cobalt and nickel is now properly arranged, right? When you talk about the atomic number, they are properly arranged. They are 27 and 28. When you talk about the atomic mass, right? So they have some confusion because the atomic mass of cobalt is more than atomic mass of nickel. If you talk about atomic mass, when you talk about atomic number, cobalt is less than nickel. So since I'm using atomic number now, right? So this issue is all resolved. Position of hydrogen is well explained because, as I told, it is done by the electronic configuration. If you see, hydrogen is atomic number is 1, electronic configuration is also 1. That means in the valence cell, the outmost valence cell, it has only 1 electron, so it is in group 1, because in this all the elements are present which has 1 electron in the outermost shell. So with this they got a position for hydrogen because the formula for grouping is different now. It is not based on the hydrides and the oxide form, but actually it forms similar hydrides and oxide, but it is based on this electronic configuration. And also answer this question that whether it is possible to have an element of atomic number 1.5 between hydrogen and helium. We can say no. Why? Because atomic number is natural number, right? So we can't have a natural number 1.5, correct? So with that, this question, which was not answered that time, it is solved now because atomic number is a natural number and a natural number can't be 1.5. That means if I say that how many elements can be between 1 and 5, let's suppose, or 1 and 6, then I can say that there are 2, 3, 4, 5, there are 4 elements between 1 and 6, right? If we talk about atomic numbers. But if you're talking about atomic mass, you tell that 1.2 and 5.8, the atomic mass of 2 different elements. How many elements can be there between these elements? You don't know because they are all decimal numbers, right? So this question was also answered with this atomic number. So the only one correction that is using atomic number instead of atomic mass solved so many issues. So the modern periodic law says that the properties of elements are periodic function of their atomic number. Please note it is atomic number, not atomic mass, right? So the basis of this law is that when elements are arranged in increasing order of atomic number, having same valence electron, this occurs at the regular interval. So the outermost electron, the outermost shell The number of electrons in the outermost shell is called valence electron. So there is it follows a periodic function. If you keep increasing if you keep arranging the elements in the increasing atomic numbers, so we'll see that this elements with the same number of valence electrons occurs in interval. For example, hydrogen, if you see, has 1, right? Then you have helium, that is 2. Then you have lithium, again that has 1, right? So the way, that's why it is. Then the helium, boron, carbon, nitrogen, oxygen. So if you see, I'll show you the table. It follows the periodicity. So let's see this modern periodic table. So elements are basis of the electronic configuration, as I told, and there are 18 vertical columns known as groups, 18 groups, and 7 horizontal rows, and they are known as periods. If you see, they are periods 1, 2, 3, 4 like this, and then they have groups, correct? Why it's called groups? Just for the memory tip to understand this, they are called groups because this group is having same property. This group same property. So if you tell a group because they have something same, right? Some chemical property the same. So all these groups have same property, and that's why they are called group. If you take this bunch of elements, they don't have same chemical property, and that's why they're never called group, right? So group is same chemical property, and that happens when you take the bunch in this fashion, right? And that's why they call groups, correct? And these are called periods, and everything is based on the electronic configuration, correct? So this guy, group 13 elements, will have example, this guy is 2, 3, right? This guy aluminum is 283 electronic configuration. So if you see, both have 3 electrons in the valence shell, right? And they have, if you take this guy, let's suppose beryllium and magnesium. Beryllium is 2, 2, and magnesium is 2, 8, 2, correct? So if you see, both has 2, and that's why it is group. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. There are some merits of modern periodic table. The first thing is, it is based on atomic number. The second thing is, it explains the reason for periodicity of the elements. It explains the reasons. The third thing is, there is no anomaly in the arrangement as we have seen in the earlier periodic tables, and the newly discovered elements could easily be accommodated in this. Also, it helps understand why elements in a group have similar property. For example, you see that all these elements in the groups we had similar properties, right? So this guy helps understand why this is happening, right? Why they have same properties, why they are all metals or why they are all non-metals, such kind of stuff. There are some advantages of modern periodic table too. First is, it made the life of chemists and the chemistry students like you easy, because just by looking at the location or position of the element in the periodic table, you can guess a lot of things about the element. It is easy to remember properties of the elements based on its position in the periodic table. There is a relation between the chemical bonding in the periodic table also. So observe that the left side element combines with the right side element and they form ionic bond. For example, NaCl. This is on the left, this is on the right. Why? Because this guy is generally metal and this guy is generally non-metal. This guy wants to give electron and this guy wants to take electron. So there is a transfer of electron happens between these and they form ionic bond. But the element on the right side combines with the element of right side to form covalent bond. For example, CO2. Why? Because both on the right, both want electron. Both are electron hungry. Both are electron. Nobody is ready to give electron, right? So in this case, when nobody is ready to give electron, they share electron and they form covalent bond. And generally, the element on the left, they don't combine with the element on the left. Left and left, they don't combine. So this is the kind of observation we got from periodic table. Left combines with right to form ionic bond, right with right to form covalent, and left doesn't combine with left. Now it's the question time. How could the modern periodic table remove various anomalies of Mendeleev periodic table? See, first thing was Mendeleev periodic table was unable to give hydrogen the place. This was cleared by our modern periodic table. Then isotopes was confusing in Mendeleev. There was no space for isotopes. This doubt was cleared again by modern periodic table, right? And atomic number was given preference over atomic mass, and with this the cobalt nickel thing where the elements were arranged not based on the increasing atomic mass but they are based on increasing atomic number, those issues were resolved, right, by atomic number. Using atomic number as the base, these issues were resolved. Name two elements which you expect to show similar property as magnesium. And I have this magnesium. Where is my magnesium? This guy is magnesium. So I know that elements in the group will have similar property. So I can pick any of this element. I can pick this calcium. This guy is strontium. These two elements will have same chemical property because all these are part of same groups and they have a valency of 2. Right? They have valency of 2. Yeah. So they will have same chemical property because I know that if you take any group, they'll have similar chemical property. Name 3 elements which has single electron in the outermost shell. Right? Single electron is this guy. All these guys will have single electron. So I can take any of this element, lithium, sodium, potassium. So I can write here lithium, sodium, potassium. All these elements will have single element in the outermost shell. 2 elements that have 2 electrons in the outermost shell. These guys have 2 electrons. So I asked for 2. I can say magnesium, calcium. 3 elements filled with outermost electron. So I know that these elements, the last one, are filled with my outermost electrons. So I can name these guys helium, neon, argon, krypton. They are all my elements whose outermost shells are filled. Very easy. If you have periodic table in front of you, you can answer to all these questions in the fraction of seconds. Lithium, sodium, potassium are all metals. They react in order to liberate hydrogen. Is any similarity in these elements? Let's see. Lithium, sodium, potassium. Yes, they have similarity, right? They are all group 1 elements and they have valence electron of 1. They have 1 valence electron. So that is the similarity, right? Helium is an unreactive gas and neon is a extremely low reactive gas. So let's see helium and neon. What if anything to do with their atom having common? Yes, they do have common, right? What is the common? Common is that they have filled outermost shell. Please note, you can't say they have 8 or 2 because this guy has 2 elements in outermost shell, this guy has 8, but they all filled because for this guy, this is K shell and K set needs only 2 electrons to get filled. So you can say that they have filled outermost shell. In modern periodic table, which are the metals among top 10 first elements? So top 10 first element, let's see the metal. Hydrogen is not metal, helium is not metal, lithium, beryllium is metal, and that's all. Because I'm talking about top 10, they are the only 2 metals, and then we are all non-metals, right? So I'll say lithium and beryllium are the only 2 metals in the first 10 elements in that periodic table. See, if you have periodic table in front of you, you can answer all these questions very easily. But if you don't have periodic table in front of you, it's very difficult to answer this question. So a lot of students memorize this periodic table, and that's advisable for chemistry students to memorize at least till 30 or 40 elements. By considering their position in the periodic table, which of the following elements would you expect have maximum metallic character? So I have Ga, Ge, I have Ga, I have Ge, As, Se, Be. What is Be? is Br actually. Br. So if you see, we know that the non-metallic character increases as we go from here to here, right? We explained that. So this guy will be the maximum non-metallic. Why? Because the non-metallic character increases as we go from left to right in the periodic table. And we've explained that. Which of the following is not a correct statement about the trend from left to right? The elements become less metallic in nature. That's correct because the metallic character is decreasing. The number of valence electrons increases. That's also correct. This guy is 1, this guy is 2, 3, 4 electrons. Correct. The atom lose their electrons more easily. This guy is incorrect because this guy is more reactive, right? And this guy is less reactive because it has to lose only 1 electron. This guy has to lose 2 electrons. So this is incorrect. The oxides become more acidic. Yeah, that's also correct. So this guy is incorrect. This is my answer. Element X forms chloride with the formula XCl2, which is a solid and high melting point. X would most likely be the same group as. See, since X forms XCl2, if you see Na forms NaCl, Mg forms MgCl2, Al form AlCl3, right? And Si form SiCl4. With this, I can say that MgCl2 is almost similar to XCl2. So I can say that this X is part of Mg. Sound good? I've got XCl2 and MgCl2, both the chlorides formula is matching. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on periodic classification of elements part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. Which element has two cells both of which are filled with electrons? That's the first question. Then I have second, third, fourth, and fifth question. To answer all this, let's take the first question. Two shells, both of which are filled with electrons. That means it has something 2 and 8 is the electronic configuration, right? Because there are two shells and both are filled. 2 plus 8 is 10. So atomic number of 10 is neon. So this neon is my answer. Electronic configuration of 282, this atomic number of 2 plus 8 plus 2 is 12. Atomic number 12 is magnesium. So magnesium is my answer. A total of 3 shells with 4 electrons valence cell. So my 3 cells and the 4 in the valence one. So 284. 284 is 2 plus 8, 10 plus 4, 14. 14 is silicon. So this guy is silicon. 2 cells with 3 in the valence electron, that is 2, 3 is my electronic configuration. 2 plus 3 is 5. 5 is this guy, boron. So boron is my answer. Twice as many electrons in the second cell as the first cell. First cell will have to be filled, right, to go to the second cell. So first cell will have 2 and the second will have 4 because twice the element in the second cell as in the first cell. So 2 plus 4 is 6. 6 is my carbon. This guy is carbon. So if you see, very easy to find the elements if I know some property of the element and I have the periodic table with me. What properties do all the elements in same column of the periodic table as boron have in common? So I have this boron. I'm asked that all these which have same column correct. So if you see, for all these my valency is 3. In fact, valence electron is also 3. V electron. What properties do I have all the elements in the same column as fluorine come? So we see the fluorine one. For all these, my valence electron is 7, right? All these are 7. You see fluorine is 279. This guy is 287. Each and every element in these group has valence electron of 7 and valency of 1. This is the common thing they have. An atom has the electronic configuration of 287. What is the atomic number? So atomic number, you add these two, all these values, so you get 17. So 17 is my atomic number. To which of the following elements would it be chemically similar? The first guy is N7, right? So this becomes 25. For this, electronic configuration will be 27. This is 15, so this becomes 285, right? This will become 288. Now I have 7 in the valence electron. So I am looking for 7 in the valence electron. That is, I am looking for this guy F. So my F9 is the answer. F9 will be chemically similar to this particular atom because both have similar number of atoms in the valence shell. So the position of 3 elements A, B, C in the periodic table are given below. The group 16, group 17. State whether A is a metal or non-metal. So you can see that group 17 are all non-metals, right? So A is a non-metal. That is confirmed. A is non-metal. Second is C is more reactive or less reactive than A. So if you see C and B, C and A, if you have to compare, right? C and A. C is bigger than A and they are non-metal. So as told, the non-metallic character decreases, right? So C is less reactive. C is more reactive, state whether C is more reactive than, so C is less reactive actually. C is less reactive, correct? Why? Because we go down, the size of atom increases, the power of neutron to, or the power of nucleus to attract electron decreases, and it will not be able to attract electrons, and thus it will be less non-metallic. Will C be larger or smaller than B? If you compare C and B, C has to be smaller because the number of shells are same, but if you go from here to here, the proton becomes powerful as compared to B, right? And then it will attract electrons more if you compare to B, and thus the size will decrease. So you can see that C is smaller than B. Correct. What type of ions, cations or anions will be formed by A? Since A is a non-metal, A will accept electron and A will become A minus. Correct? And A minus is nothing but an ion. Because I told that an ion is a negative charge. Right? A negative is an ion. So the A negative is an ion. Correct? So this guy is a non-metal because in group 17, C is less reactive because you go down, the atom size increase and the power of C to attract electron decreases. C is smaller than B or what? Yeah, C is smaller because the shells are same, and if you compare to B, C has more power to attract electron and the size will shrink. Since A is a non-metal, it will gain electron, becomes A minus, and that is an ion. Nitrogen, atomic number 7, and phosphorus, atomic number 15, that is, this guy is 25, this guy is 285, belongs to group 15 of the periodic table. Write the electronic configuration of these two elements. Which of these will be more electronegative by? So electronic configuration I wrote, this guy is 25 and this guy is 285. Now if you see, this guy has got extra shell. So if we compare nitrogen and phosphorus, phosphorus is bigger, right, and got extra shell, right? Nitrogen is smaller and got only 2 cells. Correct? Now this, since the atom size has increased, the force between this guy and this guy has decreased. So this guy is weaker, right? The atom of the nuclei of this is weaker to attract electron, and this guy can attract electron easily. So you can attract electron easily. This guy is more electronic. If I can say that my nitrogen is more electronegative. Why? Because the nitrogen atom is small and it can attract electron easily as compared to phosphorus atom. How does the electronic configuration of an atom relates to its position in the modern periodic table? So if we have seen that we have something called periods and we have groups, right? So first thing is, in a group all elements have same valence electron in a group. That is one thing. All the elements in a group have same valence electron. If we talk about periods, right? So there's a consecutive increase in atomic number. So if you talk about periods, there's a consecutive increase in atomic number if you go from here to here. So if you see in both the cases, this electronic configuration matters, correct? And they have similar electronic configuration. So based on electronic configuration, you can actually tell the position of a electron. For example, it is 282. I can tell that this guy is first, second, third period and group 13. First, second, and then you have 13 group, right? If I have something called 2-1, I can say that this guy is in first group and first, second period. Just by looking at the electronic configuration, I can tell where the element lies. So the question says calcium atomic number 20 is surrounded by elements atomic number 12, 9, 21, 38. Each of these have similar properties as calcium. So we have to find the electronic configuration. So calcium is what? Calcium is 2882. Correct. Now we'll see that this guy is 12. So 12 becomes 282. So if you see, the number matches. Thus I can say that this guy resembles property of calcium. So take this guy 19, this is 2881, doesn't match, right? Similarly, if you take 21, that becomes 2818 and 3, doesn't match. So if you see, nothing matches except this guy, correct? So we can say that this guy matches the property of calcium because they have same number of valence electrons. We'll compare the Mendeleev's and modern periodic table. So if you see, here's a comparison. In this case, Mendeleev 1, elements are arranged on the basis of atomic mass. This here, it is arranged on the basis of atomic number. There are 7 groups and 6 periods only. There are 18 groups and 7 periods. Elements with similar properties are placed in a group, and here elements with same valence electrons are placed in a group. Please note there's a difference here. Position of hydrogen could not be explained in this case. Position of hydrogen is explained. There's a isotopes confusion here. There's no confusion of isotopes. That's the difference. Let's do a recap. Elements are classified on the basis of similarity in the property. Daubernier explained grouped the elements into triads and Newlands into laws of octaves. The Mendeleev arranged the elements in the order of increasing atomic masses and also based on the chemical property. He predicted the existence of some element which was not even there that time. There were some anomalies in the basis of ordering of atomic masses which could be removed when Moseley proposed this atomic number. And In modern periodic table, we have 18 vertical columns and 7 horizontal rows called periods. And elements thus arranged shows periodicity of properties, including atomic size, valency, combining capacity, metallic, non-metallic character, all these things. It shows the periodicity in the periodic table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.